lecture number 14, Unit 3 Dynamics. So, Unit 3 Dynamics. The topic we are going to start is tension and acceleration in a string. First of all, you have to understand what is string. String is basically a one-dimension object. Here we consider string as a thread, but you have to use the terms related to the physics. So you have to be whenever you are talking about the one-dimensional object, we have to be when object is suspended or we are talking about thread, we just deal the term that is string, right? And the acceleration you have already learned in unit 2, the rate of change of velocity. The tension is new thing to you, so also you are familiar in the previous lecture, but here we will discuss in the detail, right? So the tension will be clear you when we understand this figure, right? So see this figure 3.1. You see over here there is a block which is suspended with this string. The one end, this red thread is basically a string, right? The one end of string is attached with this block, and the other end of this string is attached with this stand. So in this way, this object is attached in vertical motion. But you see that this object is in state of rest, means this object is not moving, right? But you see that there is a force whenever there is an object, obviously there is a force which tends to move the objects in a downward direction. So, and that force is basically a weight. So again, here is also a force that is acting the object downward, that is weight. But object is stationary. It's mean there is some opposite force which also acting on the block, and that is a reaction force that keep the object in the upward direction. And here the reaction force, the upward the force that is opposite to the weight is basically the tension, right? That's why this block is at state of rest. It is not moving, and it is just a state of rest, right? So this is the tension, and this is it is basically a reaction force, and direction of tension is in the upward. And one thing more you have to keep in mind, whenever we are talking about of string, there must be a tension in the string, right? So whenever we talking about a string, and here it is mentioned that if you just read out this, consider a block supported by a string, the upper end of a string is fixed with stand. This we already know. The string is inextensible, mean there is no elasticity present in the string. This string has a constant length. The one more reason is that the object is stationary, right? The string, the length of the string cannot be changed, right? So other thing is that that's why the tension will be remain same throughout the string. One thing that when there is a string, the tension is present over here, and tension and string is inextensible, means we cannot change the length of a string, so the tension will remain same in this case. So this is basically the overview of just tension, acceleration, and string. Acceleration and tension, basically these two things we will be discuss in the later topic in detail. We have to calculate, take the different cases, and we just solve the values for tension and acceleration, right? So come to the main topic, that is vertical motion of two bodies attached to the end of string that passes over a frictionless pulley. So you see over here in the figure, this statement is exactly shown in this figure, right? You see that vertical motion of two bodies. Vertical motion, you see that these two bodies, this is block A and this is block B, and they are in vertical motions along the y-axis, right? So these two bodies, they are in vertical motion attached to the end of the strings. This is the one block is attached with one end, the other block is attached with the other end, right? That passes over a frictionless pulley. When we are talking about frictionless pulley, it means the effect of friction is zero or negligible in case of frictionless pulley, right? So, and it is very necessary to keep the pulley frictionless, and string must be inextensible, because in this way we can get the our required values, right? Inextensible string is that the string that can the length of string that cannot be changed. We cannot increase the length of string. In simple words, we can say that there is no elasticity present in the string. Now we just start reading from here. Consider two bodies A and B of masses m1 and m2 respectively, right? You see that the two bodies, they are present over here, and they have we name them, the one mass is m1 and the other mass is m2, and we have seen that the m1 looks heavier than m2, so the mass m1 is greater than m2, and they are attached with the opposite end of the string, and string must be inextensible, right? The string passes over a frictionless pulley. I told about you what is frictionless pulley. So what our main task is to do over here is that this is basically our case, and we have to find out the tension, the acceleration regarding this case, right? Consider this object. This is block A. We all know that, and you see that the block A is moving downward, right? Obviously, there is a weight that is acting on this block, that is W, right? Weight is always acting downward, so this is the weight of this block, and obviously there is also a reactive and opposite force to that weight, and this force here is basically a tension. Whenever we are dealing with string, tension is always present over here, right? So we have to see over here that we have dealing with two forces. The one force which is acting downward, which is weight, and the one force that is acting upward is basically a tension, right? So in this way, the block is hanging in a vertical motion. It is in a vertical motion, right? And we see that there is also another block B, right? And also there is the weight is also applying on this block B, which is acting downward, and we know the value of weight over here is m2g. Similarly, there is also reactive and opposite force in this case of block B, which is moving this block in the upward direction, and that is tension, right? So as the both object, they are in vertical motion, the tension is along the string, right? As we know that the both object, they are masses, and they are of different masses. When they are of different masses and they are moving, they are moving with some velocity, and then if there is a velocity and the velocity is changing because of the motion of the two object, and velocity is changing, it means acceleration is produced over here, right? So we have to keep in mind the acceleration is produced in this case, and acceleration will remain same throughout the string. Mean acceleration cannot be changed. Velocity is changing, but acceleration is not changing. All right. And the other thing is that tension is also same throughout the string, because we are dealing with frictionless pulleys. There are no external factor that affect the motion of a string as well. And second thing is that the string is inextensible, mean we cannot stretch the string, we cannot change the length of string, so tension will also remain the same in this case. So keep in mind, acceleration and tension both will be remain same. Force, all right, and force we are applying will be different on block A and block B regarding their masses, right? So just consider block A. When force is applying on block A, obviously it has more tendency to move downward, as you shown, it's shown in the figure, right? So what over here, and there is a tension, but see the body is more likely to downward. It means it has more weight, and it is moving upward, but the tendency of moving upward is less as compared to the we can say that to the motion, right? So there are two forces basically. So we can just write the equation over here, and we just form the equation for we just form the equation over here like this. Net force acting on a body A is weight and tension. We take weight as positive because weight is more tendency to moving downward. We keep it positive, and tension is moving upward, so we take it as negative. And we know that W is m1g, so we write over here m1g minus t, and F1 as Newton's second law is applicable over here, because mass is there, velocity is changing, acceleration is producing, so F is equals to ma. We write over here mass is equals to m1a, so we write the equation as m1a is equals to m1g minus t, right? So in this way, we generate the equation for body A. Similarly, if you see the body B, there is also weight is applying over here and tension is also there, but body is likely to move in upward direction. So it's mean in this case, tension is more as compared to the weight. So we keep tension as positive quantity and M2 weight is as a negative value, right? So the net force acting on a body B is T minus M2G. So F2 is equals to M2A. This is basically second law, which is applicable over here. And we just Newton law is applying over here because body is in motion, acceleration is producing over here. We just substitute the value of force, which is M2A, which is equals to T minus M2G. This is our second equation, and we just combine equation number 1 and equation number 2. So when we add this equation, we get the value of acceleration. The equation 1 is M1A is equals to M1G minus T is equals to M2A is equals to T minus M2A. So when we add this equation, we get the value of acceleration. So M1A plus M2A is equals to M1G minus M2G. We just separate the acceleration because A is coming common in this equation. We just separate the G because we can take the G as common, and we get the value of A when we take M1 plus M2 on the other side. This is the value of acceleration in the case when both objects are hanging vertically, right? So in the similar way, we can find out the value of G with this above equation. This is basically the acceleration due to gravity. If there's some questions come in the exercise, sorry, in quiz or in some kind of test, so you just use this equation as well, right? So this is the value of acceleration due to gravity. You just change the value, you just separate the G in this case. The third main thing is you have to find out the value of tension. So how you can find out the tension? You just generate the equation 1 and 2 in the previous slide. You just divide this equation and you get the value of tension. So this is our equation number 1 and this is our equation number 2, right? So you just divide the equation M1G minus T by T minus M2G, which is equal to M1A by M2A, and you just cross multiply it because on the left hand side you cannot cancel because there's a negative sign between two values, and if there's a negative sign between two values you cannot just simply cancel out. But on the right hand side you can just cancel out the acceleration because they are just dividing with each other, right? So just when you do the cross multiplication, you get M2 is equal into M1G minus T is equals to M1 into T minus M2G, right? So just multiply M1 on the left hand side and M2 on the right hand left hand side and M1 with on the right hand left hand side, and you get the arrangement M1 M2G is minus M2T is equals to M1T minus M1 M2G. Just take the similar quantities on one side like this. M1 M2G will be moved on the other side with positive sign, and you see over here, and M2T will be moved on the other side with on the other side, and its sign will be changed as positive sign, right? So you just know that 1 plus 1 give us 2. So here we can write as 2 M1 M2G, which is equals to M1 plus M2 into T. So when you separate the T, you can just get the value of tension, which is 2 M1 M2G by M1 plus M2, and this is the value in the case when objects they are attached vertically, right? So now come to the other example. This is example number 3.4, and it is related to the previous topic that we have just learned, right? So this is example number 2. Two masses 5.2 kg and 4.8 kg, they are attached to the end of an inextensible string which passes over frictionless pulley. Find the acceleration in the system and tension in the string when both the masses are moving vertically. So that is given to you, M1 is given to you, M2 is given to you. You just need to memorize the formula and just put the value in the formula of acceleration, and you get the value of A. And similarly, you know the formula of tension. You just put out the value in the tension formula, and you just get the value for tension. right? In this way you can solve this example, but you have to keep in mind that what is the motion of bodies. If it's in vertical motion, then this formula will be worked out, right? So the second thing is that you see here, do you know, an Atwood machine is an arrangement of two objects with unequal masses such that, shown in figure 3.12, both the objects are attached to the end of string. The string passes over a frictionless pulley. This arrangement is sometimes used to find out the acceleration due to gravity. Atwood machine is basically that machine, the topic which we just learned. This is basically working on the working of Atwood machine, right? Because the two masses are there, they are attached with an inextensible pulley, frictionless pulley, and attached and passing through inextensible string. So these all work on the Atwood machine, and the basic purpose of Atwood machine is that we can find out the value of acceleration due to gravity, and the value of acceleration gravity in this case is G is equals to m1 plus m2 by m1 minus m2 into A. All right. So our next topic is motion of the two bodies attached to the end of string that passes over a frictionless pulley, such that one body moves vertically and the other moves horizontally. If you see this statement and just see out the figure, it is very clear to you that there are two bodies. One is block A, another is block B, and the two ends, they are string. The strings, they are attached to the two ends. See, the string is attached over here at the one end of the block B and the other end of the block A. And it's also mentioned over here, the pulley is frictionless. I told you about what is friction. Means the effect of the effect of over friction over here in this case is zero or negligible, right? And the one body is moving vertically. You see that the body A is moving vertically, and the other moves on a smooth horizontal surface. Mean the other object, this is placed over here, is in horizontal motion, right? So, so class, please unmute mute yourself, right? Okay. So we have to generate the equations for this case. First, we have to consider this case, right? This is a block A, and we see that it has a vertical motion and it is moving downward. So it must be has a weight, which is W is equals to m1g. And obviously, it is also has some reactive force, which is opposite in direction, and that is tension over here, because string is in vertical motion. So tension is acting against the weight, right? And whenever there's a string, there must be a tension, keep in mind. And the acceleration is also producing an acceleration. The direction of acceleration is downward because it's moving over a pulley. So first we see that the force acting on body A is m1g minus t. How? Let's see it. M1g is basically a force acting downward. We take as positive because the object has more tendency to move downward. And the other force is tension, but the object is not moving upward. There is tension, but there is less tension. So we take it as with negative sign because the force regarding tension is less. So we take it as negative sign, and the force regarding weight is more. So we write it with positive sign. So we can say that force is F1 is equals to M1g minus T according to the Newton's second law of motion. See, as there are masses, so obviously they are moving with some velocity, and the velocity is changing, right? So class, please hold a second. I have to put my laptop with the charger because it's about to close. Just wait a second, okay?
Okay.
And please unmute yourself, right? So, okay. So as a Newton law is applying over here, so we know that the mathematical form of Newton's second law is ma. So here mass is m1. So we write here, instead of f1, we write over here is m1a, which is equals to m1g minus t. And this is our equation 1 for the block A, right? All forces that are acting on block A, we write that in this form of equation, right? So now see the body B. Do you see that there are forces that are applying on the body B? Yes, there are forces that are applying on the body B, right? One is obviously weight, which is acting downward, and W is equals to mg, and we write here as W is equals to m2g because we are dealing with mass, which is m2, right? And there is an opposite force regarding weight, which is a reaction force that is in upward direction. And keep in mind, the string is in horizontal direction, so the tension is along the string. So the direction of tension is moving horizontally, right? Here the reactive force and another force that keep the object on the table, right? And you see that the object B is not acting downward. It is not moving downward. It is just moving horizontally, as you shown with the help of arrow. You see that this object is moving horizontally. It is not moving downward, right? So in this case, what happened? The weight is also equals to 0, and the reaction force, it is also equal to 0. So the effect of, there is no effect of reaction and weight. That's why this object is stationary, is at rest, and it is moving. It is not moving downward, but it is moving horizontally because tension is acting horizontally in this case, right? So we just read out from here. The forces acting on body B are weight m2g of the body acting on the downward. If, this one force is applying in the on the body. Reaction force of the horizontal surface acting on body B in the upward direction. And the third is tension T in the string pulling the body B horizontally over the smooth surface. So these three forces are applied, but applying on the block B, but reaction force and weight of weight is equals to 0, right? And there exists only tension, right? So if you see that there is no vertical motion in B, I just told you, so it's mean that m2g and r must be equals to 0, right? So the only force, the only resultant force, the net force acting on a body B is T, and here T is equals to T. So according to Newton's second, this is the force, right? This is the formula, F2 is equals to T. And obviously Newton's second law of motion is also applying over here because it has mass, its velocity is changing, and when velocity is changing, acceleration is produced and force is also produced. So this obeys the second law of Newton. So we place the value of Newton, F is equals to ma instead of F2, we get T is equals to m2a. Right? So this is the value for equation number 2. And our main aim is to find out the value of tension and acceleration in this case as well, right? So we can find out the value of acceleration if we just acceleration, if we just add up the equation number 1 and 2. This is equation number 1 and this is equation number 2. We just add, and you know that when we add the two quantities, there will be no effect. They will be applying the same operation as they are, right? So m1a plus m2a, which is equals to m1g, t will be cancelled out with t because they are with opposite sign, right? So we can take common a. From this equation, we get m1 plus m2 into a, m1g as it is, and we find out the acceleration. So we just take the m1 on the other side, we get a is equals to m1 by m1 plus m2 into g. This is the acceleration in the case when one object is moving vertically and other is moving horizontally. So you have to do not get confused regarding, because there are two different cases. In one case, their objects, they are moving both in vertical motion, and in this case, the one is having a horizontal motion and other is having the vertical motion, right? So again, we can find out the value of tension as well from this equation. So what we have, know that we just generate the equation number 2, which is basically the T is equals to m2a. This is our equation number 2. So putting value of a in the above equation is T is equals to, here we put the value of acceleration right over here, which we calculated in the previous slide, right? So T is equals to m1 m2 by m1 plus m2 into g. So this is the value of tension in this case, right? So see the example number 3.5, which is similar to the case which we have just learned. So this is, there are two masses, 4 kg and 6 kg. They are attached to the ends of the inextensible string, means there's no elasticity present in the string, which passes over frictionless purely, means friction is 0 over here, such that mass is 6 kg is moving over a frictionless horizontal surface, and the mass 4 kg is moving vertical downward. Find the acceleration in the system and the tension in the string. So m1 is 4g and m2 is 6g, and just substitute the value in the formula of acceleration. You get the value of acceleration, which is 4 meter per second square, and there is a value for formula for tension as well. You just substitute the value and you get the required value of tension in this case. All right, so these are the our topic for today. Just hold a second. So hope you will understand these topic well. Now there is a homework for you. What you have to do, you have to solve these question in your notebook. The question number one is very similar. The topic which we'll discuss in the start. Calculate the tension and acceleration in case of vertical motion of two bodies attached to the ends of string that passes over a frictionless pulley. Means the case in which we are dealing with two motions vertically for two objects, we have to solve the derivations. We have to draw a diagram and calculate their tension acceleration in question number one. Then question number two is very simple. It is just you have to define the Atwood machine and what it is used for. Right, I already told you in the in the previous slide. The question number three is calculate the tension and acceleration in a string during motion of two bodies attached to the end of string that passes over a frictionless pulley such that one body is moving vertically and the other moves on a horizontal surface. That is the case that we just studied. So this is basically your homework.